Assalamualaikum. My name is Muhammad Aiman bin Aziz. My metric number is F25B1614. Okay, the question A describe how the genes originally linked in the trihybrid parents. Okay, to determine the original linkage arrangement, we first identify the two most frequent progeny classes because they represent to the non-recombinant parental types. This way, kidney, cardinal, and ebony the corresponding gametes K small c small e big and K big c big e small, showing that the F1 female carried the chromosome in the arrangement K small c small e big over K big c big e small. Okay, thank you. We move. Okay, we move to the next slide. The genes in the F1 trihybrid female were linked as this. And the chromosome 1, K small, C small, E big, chromosome 2, K big, C big, E small. The parental linkage arrangement is K small, C small, E big over K big, C big, E small. Okay, thank you.
Thank you to Ayman. My question is B. Based on recombination frequency, the gene order is K, E, and CD. The distance between K and E is 7.0 centimorgan, while the distance between E and CD is 5.0 centimorgan. Therefore, the total distance between K and CD is 12.0 centimorgan. Okay.
Question C. Calculate the interference in operative. Formula of interference is I equals 1 minus C. C is observed double crossing over, divide expected double crossing over. Expected double crossing over frequency is 0.07 multiply 0.05. Result of expected double crossing over frequency is 0.0035. Expected number 0.0035 multiply 4000. Result of expected number is 40. C equals 40 divide 40. Interference 1 minus 1. Result of interference is 0.
For question D, I calculate the expected result of double crossover or DCO. First, I identify the double crossover of spring by selecting at least frequent progeny classes. In a 3-point test cross, double crossover events occur less frequently than parental and single crossover events. Therefore, the classes with the lowest numbers are considered the double crossover classes. From the data, the two least frequent classes are kidney, ebony, cardinal with 6 offspring and wild type with 8 offspring. Next, I add this value together to determine the total number of double crossover offspring. Total DCO equals 6 plus 8, which gives 14 offspring. To calculate the DCO frequency, I divided the total number of double crossing over offspring by the total number of progeny, which is 4000, and multiply the result by 100. The calculation is 14 divided by 4000 multiplied by 100, giving a DCO frequency of 0.35%. This means that only 0.35% of the offspring were produced through double crossing over. Since the frequency is very low, it shows that double crossover events are rare among the progeny. Therefore, the expected result of double crossing over is 14 offspring with a frequency of 0.35%. This result is expected because double crossover require two crossover events to occur in the same chromosome region, making it much less common than single crossover event. Thank you.